In this lab, we're going to teach you how to use the mass of an object and the volume by displacement of water to determine the density of a substance. To turn on the balance, you first need to plug in to the back of the device. Wait until the display shows 0.00 grams. In the instructions, it asks you to make a prediction given 5 objects. We have 2 rods that are 5 centimeters long. One is silver colored, one is gold colored. We've got a marble, a penny, and then a 10 centimeter long rod that is also silver colored. Which of these 5 objects do you believe will have the greatest mass? Which one do you believe will have the least mass? Now, the second prediction involves volume. Volume is the amount of space an object occupies. Which of these 5 objects takes up the greatest volume? Which of these objects takes up the least volume? Let's find the mass of each object. Because these items can roll, I'm going to put a weighing boat on. The weighing boat has mass, so I'm going to zero the device. It now reads 0.00 grams again. Here is the mass of the gold colored 5 centimeter rod. Here is the mass of the silver colored 5 centimeter rod. The mass of the marble. Mass of the penny. And finally, the mass of the 10 centimeter silver color rod. Double check that you have recorded all 5 of these values. In part 2, we are going to measure the volume of each of the 5 objects by using the displacement of water. Take a 50 milliliter graduated cylinder, fill it up to 25 milliliters. Remember that when we use the graduated cylinder, we want to look for the area that scoops downward and make sure that it lines up with the measurement we're looking for. I have too much water in here right now. When we put the first object in, we are looking to see how much the water will raise. So tilt your graduated cylinder at a 45-degree angle and slowly slide the object down in. We don't want to splash out the water. We then read the new meniscus and record. And then you can dump out the water into the sink and remove the object. You need to repeat these steps for the next 3 objects. Object number 2 is the silver colored rod. Turn your graduated cylinder at an angle, slowly slide the object into the graduated cylinder, reading the new level. Object number 3 is the marble. Object 4, the penny. Since object number 5, the 10 centimeter long silver rod, is substantially larger than the others, it is recommended to use the larger 100 milliliter capacity graduated cylinder. This time I'm going to put 50 milliliters of water in to start. So we'll make sure to record the starting water volume as 50 milliliters. Remember, this is an exception, not what we did for the first 4. Turn at an angle, slide the largest object in, being careful not to splash, and then record this new volume.
All right, so now that Mrs. Harris has walked you through how to get the measurements of our cylinders and our marbles and our pennies, we're going to go ahead and take those measurements and use them to calculate the final density of our objects. And again, this is an important skill to have because when you calculate the density of an object, it's what we call an intensive property and allows us to potentially figure out what that object might be. Okay, so we're going to start by taking what measurements we have, and that's what we call our given measurements. So we're going to start with our given values. So for starters, we had our mass of our cylinder. Our mass of our cylinder was 54.67 grams. So we're going to mass M equals 54.67 grams. G. Never forget your units whenever you're doing a calculation. I know it's easy to just want to write the numbers and plug them all in and slap them all together, but you need units to make sure that your calculation is what you're looking for. Okay, now we have 2 volume measurements. Which one are we going to use? Well, we want to use both. We have first the initial volume. So we're going to call that V and then a little I, which means initial, or the starting volume. And that initial volume was the water that we put into the graduated cylinder before we put the object in there. And that was 25 milliliters. Okay? We have our final volume, which we're going to call V little f. Okay? And that's the volume that our water rose to after putting the object inside that water. And it rose to about 31.5 milliliters. Okay? So again, which one do we use? Well, we're not looking for the volume of water. We're looking for the volume of the object. And remember that the volume of the water rises by the volume of the object that you put in there. Like Archimedes in his crown, when he put the crown inside, or when he got in the bathtub, it splashed all the water, displaced that water by the volume of whatever went into that water. So we need to take the difference between these two. the volume of the object is equal to the final volume, which is what the water rose to, minus the initial volume. So that's going to be VF minus VI. We can go ahead and plug and chug our numbers. So 31.5 milliliters minus 25 milliliters. Some quick head math will tell me that is 6.5 milliliters. So the volume of my object is 6.5 milliliters. Okay, so now that you have the volume of the object, you have the mass of your object, now you can use those two to calculate density. So what is density? Remember, density is the amount of stuff you have in a given amount of space. So our amount of stuff is our mass, and it's per our amount of space, which is our volume. So that's going to be density equals our amount of stuff, mass, per or divided by the space that we take up, the volume. So D equals M over V. That's an equation that you should be pretty intimately familiar with at the end of this year. D equals M over V, I'm going to write that out, and then I'm going to, again, plug and chug. I'm going to insert my mass on the top, 54.67 grams, and my volume on the bottom, which would be, again, the volume of my object, 6.5 milliliters. Common mistakes here would be to use the volume that we started with, 25 milliliters, or the volume here, 31.5 milliliters. Don't make that mistake. It's what the volume changed by. All right, so quick head math. I'm calculating this. That should be about 8.4, okay? And that's going to be in what unit? You can't just have a number. That's not good in chemistry, just have a number. We need a unit for that. So what unit would that be? Well, it's whatever units you used in your equation here. So we have grams and milliliters. Those don't really go together, so we're just going to write them both. And that's okay, you can do that. So it's going to be grams on the top over milliliters. Okay, so when you're done with your final answer, I always like to put a nice box around it or a circle or something to show that that is my final answer. I need a number and I need a unit. Okay, so that's how you calculate density.